Yeah, another robotic arm video. So yeah, this is my Scara robotic arm. I believe this is like part 3 already. I've been working on it a little bit. I've done a few updates mechanically and some electronic updates as well. I'm going to go over how the electronics works in this video briefly. There are much better videos out there explaining how everything works, but I'm just going to go over it very quickly. The biggest design change I made was I designed this component, and this thing is just going to go on top. So I've had a bunch of trouble with the Z-axis making a bunch of noise, and someone suggested that maybe it has some load on it, so the weight of the carriage is pushing down on the stepper motor, and you know that might be true. So to mitigate that, I'm gonna move it up. I also made this new component so that you can slide it back and forth a little bit, so that you know any play or any friction or whatever that is caused by this ball screw or lead screw, sorry, not being aligned is mitigated using that. So yeah, that's basically the idea. I'm going to see if that works. Hopefully that reduces the noises a little bit, but I'm not too happy with this lead screw design. It is quite simple and quite cheap, but you know, it's kind of slow and noisy. So in the next generation, I think I'm going to replace this with like a belt. But that, you know, requires a complete redesign of sort of the base as well. But it'd be nice if everything is sort of belt driven instead of like lead screw driven. But you know, with a belt, it's not going to have that much holding force, so it's going to always slip down, or I need to use like a counterweight, and I think a counterweight is going to be kind of nice. But there's a bunch of little updates I want to do. So I was like, this one, I think this stepper is way too far forward. There's kind of a bit of weight in this arm. So this stepper motor in the base here is kind of struggling with that. So yeah, I might want to update that as well. The biggest update I've got is like these things. And I made a little video about these as well, but they're pretty cool actually. There's like little PCBs that turn these stepper motors into servo motors. So I got this one fully assembled, and I'll show you how it works. I got a video about them, a little short video, but it's basically this PCB, and you put like a little magnet on the back of the stepper motor, and then there's a little Hall effect sensor in the middle there, and then you place this on the back of the stepper motor, and it can record its position. So it's basically a servo motor. And these are really cool because they've got like all the drivers on here as well. So all you need is like direction and step as an input, and it's just gonna run. And these things are a lot more powerful than the ones I've been using. So this is the new one, and these are the old chips. So basically what this does, this is a 4988 driver, and this has different drivers, but they're more powerful. But you know, basically this one just gives directions, gives a signal input, and then the stepper motor should turn. But this one has position feedback, so it knows which position it needs to be at, so how many degrees it needs to turn, and it will provide power as long as it's not at that position. So that's really good. So I think these are more powerful, so that will definitely help with the Z-axis as well. I'm gonna hook everything up, and I'm gonna briefly explain how the electronics work. And you know, there's way better videos out there of people explaining how this works, because this is basically a CNC shield. It's not really designed for robotics, but it does work, especially if you use stepper motors. But down here, this is just like a regular Arduino. And then on top of there, this is a CNC shield, and a CNC shield just, you know, makes more pinouts. So instead of having only these 2 rows of like pinouts, you've got all these extra ones where you can plug in these sort of driver boards. And these are, you know, universal A4988 driver boards. And the new ones that I'm going to use, they're this one, and that uses a little cable. But I'm going to plug it in and then show you. So I've got the electronics wired up now, and it's very simple. This is a Arduino CNC shield, and underneath it is a Arduino Uno, I believe. And the Arduino shield basically just takes the pins of the Arduino and makes more of them, if that makes any sense. So you can plug in more things. And right here you've got the old drivers, the A4988s, and these are the new drivers, or this is not really a driver, just a pass-through. This is so that you can plug in these new cables, and these new cables, as you can see, and they've got a few more wires than the old cables, and they go up to the PCB at the back of the stepper motor. And as you can see, it has a little LCD screen that shows you, you know, how many degrees it's turned. There's a bunch in there as well. If you type menu, there's a lot. I don't know what half of it means. So if you're familiar with these, please let me know. There's, you know, they're from China, so there's very limited resources out there to explain what they do, how they work, what the software they're running. So it's, you know, it's pretty hard to find out how they work. Most of it I get somehow, a little bit, but if you have more knowledge about it, please let me know. I'm very interested to learn more about these machines. So yeah, I'll go over all the software that I'm using. I'll start with this. This is Universal G-code sender, and as the name implies, it sends G-code. G-code is this code down here. This is what G-code looks like. And so G-code is just positional code. So it just tells the Arduino where the end effector needs to be in X, Y, and Z direction. So this is a 3D representation. So right now I'm 0, 0, and then when I'm going to give it movement, it's going to change its position. So this sends the G-code to the Arduino, and on the Arduino I've got something installed called GRBL, and GRBL is a piece of software that turns G-code into signals to move the motors, basically. So that's what's happening on the CNC shield. So the Arduino sends signals to the CNC shield, and then it tells the stepper motors to move, basically. So GRBL, I'm running GRBL 0.9, I believe. It doesn't really matter, the new one's a little bit better. But I'll link to a video how you install this. It's really simple. You download the Arduino IDE, you download GRBL, whatever version you want to run, and then you flash it onto the Arduino, and then you're set, basically. Now it can interpret G-code and turn that into movement of the stepper motors. So I'm going to connect it up. So here again, you can see the software that I'm using is GRBL. So I've got GRBL installed on the Arduino on my machine. So I'm going to use GRBL, but there's a few more of these G-code interpreters. You can, you know, do your research if you want to find out if another one is better suited for your application. You have to select the right port, and what they mean by port is just basically your USB port, so which USB port you are using. As you can see from me, I've got Bluetooth and Arduino. It detected the Arduino on the first port that I'm using. Have to make sure that you set your baud rate on the right speed. This is basically how fast signals go over the wires. As a default, this is the right number. Sometimes, for whatever reason, you have to change it. I've had that it jumped for whatever reason. But usually this is fine. And then you're just going to connect up, and hopefully it works. Yes, it's okay. So now it's connected. So as you can see, like, these are not hooked up. So you can see that this is the Z-axis, this is A-axis, which is basically usually the extruder, and you have X, and then here somewhere you can see that that is the Y-axis, but they are all not hooked up, so they won't do anything. But the Z-axis is hooked up, so if I go ahead and manually jog the controls, so here you have got sort of manual controls, you move the X, Y, and the Z direction. So if I start moving the Z direction, the motor should start moving, and it does. And as you can see, the position goes up. So in the G-code sender right now, the yellow piece moved up, so we're in a different position. But I'm so impressed how quiet this thing is. I'll run it again for you. It's like, you know, you can barely hear a thing. That's insane, right? Like if you're used to the whine of like 3D printers, they, you know, the stepper motors, they make a bit of noise. This is insanely quiet. It's so cool. You can see as well 280 the degrees, the top number. That's how far it has turned right now. It's like, I just can't believe how quiet these are. These are such good drivers, right? Here again, if I go back, there's actually quite a bit of force. It's able to, you know, move, resist my pressure, my strength pretty well. So yeah, I'm really impressed with these things. Again, I'll have a link in the description where you can buy these. And if you know more about this software, please let me know. It's like, they're from China. It's really hard to figure out how they work, but they're really cool. And they're not that expensive. I believe that I bought this entire unit for like 20 bucks, which is, I think that's pretty cheap for especially how quiet and how strong it is. That's amazing. So yeah, that's basically how these electronics work. It's not that difficult, and I think anybody can do it themselves. And there are way better videos out there telling you how to install GRBL and how to use, you know, G-code. I don't think Universal G-code Sender is the best, but it works for me. It also isn't quite the best for robotics platforms because it's more designed for 3D printers, which move in X, Y, and Z directions. These move in, you know, a little bit more complicated directions. So I'm working on a little Python script to turn, you know, to make a kinematic model of the robotic arm so that I can turn the movements into G-code. But that's proving a little bit difficult for me. So if you've got experience with that, you know, please let me know, hit me up. So yeah, that's how it works. If there's any questions, please let me know. I'm happy to make another video. I'll be installing this thing next, and hopefully that fixes a bunch, but I don't know. So yeah, let's do that. So to wired everything back up again, I installed this servo stepper motor onto the Arduino CNC Shield, and holy shit, it's quiet. All right, I had a big problem with the last one. Made a ton of noise when I was moving the axis, the Z axis, but this one is super quiet. Here, let me run it for you real quick. You can barely hear it. Like I'm going to show you that it is definitely running and then moving up and down. You can barely hear anything. That's absolutely amazing. I'm super impressed by these little PCBs. That's absolutely amazing. So I'll definitely be installing them on the other two stepper motors as well. I'll have a link in the description where you can buy these. The only problem I've had is that when I was plugging everything up and I wanted to connect the Universal G-code Sender to the Arduino, it wouldn't connect for some reason. And then when I tried unplugging the stepper motor and then connecting, it would work. And then when I then plugged the stepper motor back in, everything worked fine. So I don't know what that's about. If you know, please let me know in the comments down below. But yeah, I'd like to fix that. That's a weird little bug I'm running into right now. But yeah, make sure to subscribe for the next video, because I'll definitely be making updates on this project as well. So yeah, see you.